Yeah, good evening, dear students. Today I am going to explain application of integrals, especially then I am going to explain 9 problems related modulus functions. If you prepare this, all types of modulus functions I am going to cover. You will get an idea about this. So here today, the 9 problems, try to understand. If any doubt, please ask me again and again. You can ask me in the chat box. I can repeat the problem whenever you want to explain. I will repeat that problem. So I guess now I'm showing, because I'm presenting the questions now. You can see the questions I'm giving, 9 questions I'm presenting on the screen. Those questions one by one I'm going to teach you now. All are important questions, one by one. Today topic, application of integrals in modulus functions. If we solve this, you get an idea how to solve modulus functions with given functions. Okay, fine. Now I will start now. So just in between, if you have doubt, in the chat box, let me know. Definitely I can help you how to solve that. One by one solve that. Yeah, who are presenting, even you can share your names in the chat box. Now, within 1 minute, I am going to start the class now. So you have seen these are the problems, 9 most important problems in application of integrals. Today's topic is this. Okay, now I will discuss now. See the problems now, one by one I will discuss now. See the first problem, find the area bounded by the lines y equal to modulus of mod x minus 1 and the x-axis. So that is the first problem. Here try to understand the problem, then I will explain. First we will sketch the graph, then I will explain how to find the area of this. Area of this one. First one you can see, find the area bounded by the lines modulus of mod x minus 1 and the x-axis. So that is the first question problem you can see here. What I would explain here, they are asking here the function. When I have taken this one, so the first one I can write y is equal to, think about the problem. When I am explaining the problem, right. So they are given the problem here, y is equal to modulus of mod x minus 1, right? The first one. We have modulus of mod x minus 1 and the x-axis is clear, right? And the x-axis. Because these are the problems, you have seen this, then one by one I am going to explain now. Right. So look at the problems, one by one I will explain. In the screen I have seen this. Right. The first, you can just, I will explain the first one now. See the first problem now, y is equal to modulus of mod x minus 1 y is equal to modulus of mod x minus 1 and the x-axis. And the x-axis is clear, I think, right? Just 1 minute. The problem, just get an idea about this. Just 1 minute. This is taking time now. Yeah. y is equal to mod x minus 1. And they're asking, and the x-axis. So the first problem is, I told that only right. And they're talking here, y equal to modulus of mod x minus 1 and the x-axis. So when they're talking and the x-axis here, first you write the given function is this one, y equal to modulus of mod x minus 1. But we know that mod x, the definition of mod x, just you remember. What the definition of mod x is equal to x when x greater than or equal to 0, equal to minus x, as you remember the definition of this, when x less than 0. You remember this. If you remember, as per that you can write now, see the given function I can write. First you follow this, then when mod x equal is when x greater than or equal to 0 means, then what about whenever x greater than or equal to 0, the function will become y is equal to, since mod x equal to x, it will become mod x minus 1. It will become mod x minus 1. When x, you see here, then when x greater than or equal to 0, y is equal to mod x minus 1. Again, here I should split this. From this I can write, we know x greater than or equal to 0. But if x value is more than 1, the y value become, you can see now, when x value more than 1, you can observe here, y equal to, it comes again, if x value more than 1, it comes x minus 1 when x greater than or equal to 1. If x value less than 1, it will come minus of x minus 1 if x less than 1. That is important here. You observe that. In the case of x greater than or equal to 0. Similarly, you can think when x less than 0. When x less than 0, the function whenever x less than 0, whenever x less than 0, here I can, in this case I can write when x less than 0, when x less than 0, I can write y is equal to, we know that this is a, since less negative means this will come mod x minus 1, correct, inside, because already you know that x less than 0 mod x equal minus x. So this expression I can write, in this case you observe here, y equal to x minus 1. So mod x equal to minus x here less than 0. So inside it comes mod of minus x minus 1, correct. This I can split now. This you observe here. This how to write this one. Y is equal to inside minus x minus 1 is nothing but, here I can also write this function I can write here, which is nothing but mod x plus 1. Correct? Mod x minus 1 is nothing but mod x plus 1. Mod x plus 1. From this we can decide now this one, y is equal to, since it is mod x plus 1, right? Mod x plus 1. So the x value, suppose mod x plus 1, if x greater than this x value greater than or equal to minus x plus 1, so this is 0 at minus 1, 0 at minus 1. If x value greater than or equal to minus 1, it comes x plus 1, y is equal to x plus 1 when x value greater than or equal to minus 1, and is equal to minus of x plus 1, minus of x plus 1 when x value less than minus 1, less than minus 1. Now just keep in our mind, I can draw the lines now, the area, because I should sketch the graph, that is important now. You can observe, sketch the graph is important now. You can observe here what I am doing now. Using these values, the conditions, above all the conditions, this is y equal to x minus 1 minus of x minus 1. Just you observe the graph, this one. First we will sketch the graph. Now it's coming a line. You draw a line like this. You can write this one, you draw this one. So x axis, y axis, I can draw this. Consider this one. So y-axis, I have written this one x dash and x-axis. Correct. This is y dash. So you take, we have graph y equal x minus 1, x greater than or equal to 1. So you see in the graph, you see x value 1 or more than 1. So if you take the point 1 or more than 1, you take this point 1. When 1 or more than 1, the function is y equal x minus 1. So you will get the graph y equal x minus 1 like this. The extended y equal x minus 1. The graph will go above, it will come like this. I can draw this one. Be careful here. When I have taken this one, I am drawing that x equal to 1. Just the line will go up. X equal to 1. Correct. X equal to 1 more than 1. Because this is the line graph of y equal x minus 1. So you see this is the graph of y. This is y equal x minus 1. Y equal to x minus 1 graph. Now you have taken this. Again you can see the graph. Minus of x minus 1 when x less than 1. When x less than 1. That means minus of x minus 1 is it comes 1 minus x. This will be 1 minus x. Here also x less than 1. So taking x less than 1. The graph will come x less than 1. So because I can join that graph. Be careful, the graphs when I am drawing, you should be careful here. The line, I think, sorry, the lines are coming. Why? Because here when x equal to 0, if we put x equal to 0, in this you will get 1 only. The graph touches like this. This point it touches. Because at x equal to 0, this is the graph, there is a required one. It go like this. It will come like this, but we don't want that much total. So here the graph will come like this. This one. Why? Because, and I can draw this one. Say another case. They are intersecting the same point. You should consider they are intersecting the same point. This graph will come like this. Right, here I have drawn this. This is the graph. You can see now the functions here. When I have taken this one, this is the graph y is equal to, this is the line, y is equal to x minus 1. So this is 1. Here this is 0. If you substitute 0 in any graph, it comes 1 only. This point 0, 1. So this is the line. You can see. This line you can see. This is the line x less than minus 1. This is minus 1. X less than minus 1. Y equal to minus of x plus 1. Y equal to minus of x plus 1. When you have taken this line, when you extended this line, so if you extend that line, this line. So this line is, you can write, this is actually y equal to, because you have taken, this is the case, y equal to x plus 1. Y equal to x plus 1. What about this line? This is here y equal to 1 minus x, this line. The green line, this is, because in this case, you will get 1 minus x. This is y equal to 1 minus x. Then what is the required area here? They are asking, now you can observe here. The required area is this one they are asking. This is required area. So this is required area. Correct? They are asking this is the required area. So again this is symmetric because 0 to 1 here also same thing. Minus 1 to 0 is symmetric. If the figure it was looking like that, just I can draw right side this one. The point should come here. 0 to 1 minus 1 to 0. Distance is same. This is a rough diagram. So it is symmetric with respect to y-axis. The graph is symmetric with respect to y-axis. Consider they are intersecting at this point. They are intersecting at this point here. 0, 1. They are intersecting at 0, 1. This point you can consider. They are intersecting at 0, 1. The line, please consider this is y-axis. Consider this is y-axis. They are intersecting at this is 0, 1. It is symmetric with respect to. Please try to understand the figure here. It will come like this. The shaded area is the required area. This point is I can consider this point is 0, 1. Both arrows are intersecting. Right. Now required area. So when they are asking required area equal to, I can write now the required area is equal to correct. So what is the required area? The shaded area is the required area. When they are asking to find required area, now you can see when they are asking the required area, this one. This is in symmetric. I can write 2 into 0 to 1. Because area I can write 2 into 0 to 1. 2 into 0 to 1. This is y equal to 1 minus x. So since it is symmetric with respect to y-axis, I can take 0 to 1. I can write y function y dx. So 1 minus x dx. 1 minus x dx I can consider. One minus x dx. So what is integral 1 minus x dx? It will come 2 into x minus x square by 2 limit 0 to 1. Substitute the limit 0 to 1. So it comes now 2 into, we substitute the value, upper limit 1 minus 1 by 2, lower limit if we substitute that will be 0, 2 into 1 by 2, it comes 1 square unit. Your answer is 1 square unit. 1 square unit, that will be your answer. 1 square unit. Next one, I will explain the next problem now. Anyone have doubt, please ask me that. So this is a problem now, I am explaining next problem now. The second problem. In the beginning I shared the screen. In the beginning I am doing next problem now. See the next problem. So the next problem is find the area of the triangle. Find the area of the triangle whose two vertices. Find the area of the triangle whose two vertices formed from the x-axis and the lines y is equal to 3 minus mod x. Y is equal to 3 minus mod x. I will tell you again. Find the area of the triangle whose two vertices formed from the x-axis and the line y equal to 3 minus mod x, and the line y equal to 3 minus mod x, and the line y is equal to 3 minus mod x. See, in this problem y equal to 3 minus mod x I given this. So I will repeat the problem here. Find the area of the triangle whose two vertices formed from the x-axis and the line y equal to 3 minus mod x. First you think, again we just remember definition of mod x. Again mod x is equal to x when x greater than or equal to 0. equal to minus x when x less than 0. If we follow this one, this expression I can write 3 minus mod x. So this I can express equal to 3 minus, because this 3 minus mod, this is graph now. According to this definition, I can write now. So y equal to 3 minus mod x can be written as, when x greater than or equal to 0, 3 minus x. Clearly I can write when x greater than or equal to 0. X less than 0, minus x means it will be 3 plus x. 3 plus x when x less than 0. 3 plus x when x less than 0. Now, if we draw the lines of this 3 minus x, 3 plus x lines in the graph, if we draw the lines, then the graph, it will be easy. Just you draw the lines here, then just you can observe here, when I am drawing the lines, again, if we take x-axis and y-axis, I can take x-axis and y-axis. It's coming just if we draw the, is going just you draw this, then you should draw the lines right. Please consider as x-axis and y-axis. When I drawn this, x-axis, x dash. Now you can see here, this is I can consider as the origin here. You can think that line, and x equal to 0, y will be 3, right? When x equal to y will be 3. When x equal to 0, y will be, the graph cuts on y-axis at 0, 3. I have 3 minus x, 3 plus x. You draw the lines 3 minus x, 3 plus x. 3 plus x means when x equal to minus 3, it will be 0. If we take this is the point minus 3, I can take this is the point 3, rough diagram. 3, this is the point 3. Now you can see here, when I have taken 3, when x equal to minus 3, this will be 0. Left, x equal to this will be 0. Correct. You will get 3 plus x. You will get the 3 plus x line. It comes like this. This is 3 plus x. Y is equal to 3 plus x it comes. Y equal to 3 plus x. Now, when I have taken this one, x greater than or equal to 0. If we take this value, see, when x equal to 3, this will be 0. X equal to this will be 0. You take any number between, if you take for example 2, 3 minus 2, 1. You can see the line. X greater than or equal to 0, the line will be 3 minus x. Correct? 3 minus x is greater than or equal to 0. If we take the values, it will come. Between 0 to 3, the graph will go up like this. So I can draw here the line, you can see. Same thing, be careful here. Passing through this, I can draw like this, right? So passing through this one is the line. So this line is y equal to 3 minus x. I can extend the line. 3 minus, it comes like this. Now the required area, you can see the required area, this is required area. Again, this is symmetric with respect to y-axis. Symmetric with respect to, this is the required area, between minus 3 to 3. It is symmetric with respect to y-axis. So I can write now, required area equal to, I can write required area is equal to, just you can write required area or shaded area. Required area is equal to, when I have written required area is equal to, you can see now, which is equal to, written required area equal to, this is symmetric, so I can write 2 into 0 to 3, 2 into, why 2 into, because symmetric with respect to y-axis, because this is y-axis, right? So 0 to 3, 0 to minus 3, same. 0 to 3, upper curve minus lower curve. This curve I can consider. Upper curve minus lower curve. Correct. When I have taken upper curve, this is upper curve. So required area, this is upper curve is 3 minus lower curve is y equal to 0. X-axis means y equal to 0. Correct? You take this is y equal to 0 here. Correct? Now y equal to this one, y equal to 0. In between. So I can take this is the line 3 minus x. Now I can write y integral 0 to 3 minus x dx. 3 minus x dx. When I have taken 3 minus x dx, now this will be 2 into integral 3x minus, I get x means x square by 2. X square, but limits 0 to 3 you can consider. 2 into upper limit, you will get 9 minus 9 by 2. 9 minus 9, but you simplify, it comes 2 into 9 by 2. So it will be 9 square units. Just you write answer 9 square units. 9 square, that will be your answer, 9 square units. Next third problem. Don't worry about the problems in the beginning. I have showed that. You can follow that. Questions I have given in the beginning. Please follow that. So the required area. Now I am going to explain third problem. So in third problem, just you see that in third problem, now third one, sketch the graph of y equal to mod x plus 3. You sketch the graph of y equal to mod x plus 3. Sketch the graph of y equal to mod x plus 3 and evaluate. You should sketch the graph of y equal to mod x plus 3 and evaluate integral minus 6 to 0 mod x plus 3 dx. I'll repeat. Sketch the graph of y equal to mod x plus 3 and hence evaluate. You should from that evaluate. You should sketch the graph, then hence evaluate integral minus 6 to 0 mod x plus 3 dx. So this one, when they are asking to draw the graph of mod x plus 3, then this is a simple to draw the graph mod x plus 3, right? We will do that because at x plus 3, this will be 0 at x plus 3, right? Y equal to mod x plus 3. Just think about the graph. I can write y is equal to x plus 3, then when x greater than or equal to minus 3, equal to minus of x plus 3 when x less than minus 3. Definition of mod x when x less than minus 3. Correct. Just after this you can draw the graph of this. So y equal to x plus 3 minus of x plus 3. Correct. Now you will see that graph, how to draw this graph. Greater than or equal to minus 3 and this one. So when I draw the graph again, just you remember now, I can draw now. This one I can draw this. So I can draw this is y axis. Now x axis, xx dash. Correct. Now you can there think this is origin you can consider. So now you see this one, the graph of this one. When I am talking the graph of this one, so the graph x greater than or equal to minus 3. So if you draw the graph of this, always you can see here, the graph will go like this. This will be minus 3. You take minus 3, here it will be 0. And if you take minus 1, the graph will going increasing, right side, right, towards right side. So this is the graph of y equal to x plus 3. Similarly, if we think left of minus 3, if it is left of minus 3, the graph will come. Because up to they are given up to this one, you can see here. Or between minus 6 to 0, so they are asking. I think I can extend this line for our convenience. I can extend this line. This x dash. Now if you extend this line, you can see this one. The graph will come. When x less than minus 3, minus of x plus 3. It comes minus of x plus 3. Correct. The graph will come minus of x plus 3. The values. You take any negative left of minus 3. It comes. The graph will come like this. You can see. It will. I can combine like this. it will come graph like this. So this graph. So this graph will be y equal to minus of x plus 3. Minus of x plus 3. That graph. Minus of x plus 3. Right, minus of x plus 3. They're asking between this is the sketch the graph. Correct. They're asking area between minus 6 to 0. So minus 6 to 0 means, for example, you can take the minus 6 to 0, you can write this is minus 6 to 0 this one. That means what the area they're asking now, you can see they're asking this area. Correct? Minus 6 to 0 they are asking. Only inside, right? You can check that only inside this area. You understood, right? Here. Just be careful here. Only inside part they are asking here. This line. So this is the required area. Between minus 6 to 0 is the required area. There are minus 6 to 0. But you can see here that when they are asking this area here, this is minus 6 to minus 3. But I should show here exactly this point will be in between, because here 3 units, here 3 units. The graph will be symmetric. In the rough diagram, I am able to see like this. Otherwise, if I cut here, if I cut this one, you can see if I cut this one, the graph exactly, if you want to check this, if we draw this, and if I put here, this is minus 3, here minus 6, the line if we draw this, we join this, I will get area almost, it is symmetric with respect to here x equal to minus 3. X equal to minus 3 here. So minus 3 to 0, minus 6 to minus 3, same area. This is minus 6. It is symmetric. So I can write whatever the area between minus 6 to minus 3 is also equal to minus 3 to 0. Then I get required area equal to, simply I get required area is equal to, required area equal to 2 into minus 3 to 0. Since it's symmetric with respect to x equal to minus 3 here, this is again minus 3 to 0. Again this is y equal to x by dx. So I can consider x plus 3 dx. X plus 3 dx. When I have taken x plus 3 dx, just integral. So 2 into x means x square by 2, x square by 2 is coming like this simply, x square by 2 plus 3x plus 3x limits minus 3 to 0. Apply minus 3 to 0. If apply minus 3 to 0, then you can simplify. Zero. If apply 0, everything will be 0, right? Everything will be 0. Apply with this one minus 3. You will get 9 by 2 minus 9. Now you simplify. This will be 2 into 9 by 2. 2 into 9 by 2 it comes. Then 2 will get cancelled, which is equal to 9 square units. It comes 9 square units. Next, the fourth problem. 9 square units. I hope you understood. This calculation is simple. You can calculate that. That is not that much difficult. You can solve this. Alright. When I am doing this one, Fourth problem, you see, find the area bounded by the curves. Find the area bounded by the curves x comma y such that y greater than or equal to x square and y equal to mod x. Find the area bounded by the curves set of x comma y such that y greater than or equal to x square, this is x square, y greater than or equal to x square and y is equal to mod x. This is the graph they are asking. This is x square, y equal to x square, greater than or equal to x square and y equal to mod x. Area between these two you should find. Clearly we know that take y equal to x square parabola, y equal to mod x modulus function. See here how to draw the graph of this one. Again you should find point of intersection also, where they are intersecting this. Because they are asking area between these two curves. So from this I can write the one curve is y equal to x square. And this is y equal to x square. And another one y is equal to mod x. If we do this one, I can write x square. From solving these two equations, I can write x square is equal to mod x. X square is equal to mod x. Now to solve this, I will get x power 4 is equal to x square. You transfer one side, they will get, I can take it x square common. From this you can find the values of x equal to 0 comma plus or minus 1, right? When you have taken this, when you are solving this, you will get x equal to 0 comma plus or minus 1. Similarly, if we solve y is equal to 1 means 1, 0 means 0, minus 1, you can see here, negative means, check the values, what are the points it comes, point of intersection, 0 comma 0, it comes, minus, say 0 comma 0 it comes, and it will come when it is x equal to 1, y also 1, 1 comma 1, another one, minus 1 comma 1. So these are the points it comes, 1, 0, 0, 1, 1, minus 1 comma 1, point of intersection of these two curves. Now when you are thinking of the graph of this one, now you can see, we sketch the graph of this. The graph, if we draw this, we know the graph of this one. I can consider origin this one, x dash, y dash. You draw the graph of this one. I can write like this. This is mod x graph. So we know that in the mod x graph, this is a line y is equal to x. So this is a line y equal to minus x, because mod x equal to x when x is positive. Mod x equal to minus x when x is negative. But the parabola y equal to x square. Think about the parabola y equal to x square. The graph will come like this. The parabola, the graph will come, you can see. The graph passing through this. It will go up like this. Parabola graph. This is a parabola graph, right? So the required area, when they are talking required area, this is a required area. I can consider in between. Right? Because that will be the required area, right? I can consider that's the required area. Why? Because you take any other, I'm using this one. Between this line. Between the curve and the line, this is the required area it comes. Correct? The area it comes like this. The line between, that's the required area. You can consider the required area is like this. So when I have taken the lines, this one, required area, again, it is symmetric with respect to both the axes. And also we know the point of intersection. This point is 1 comma 1. And this point we know that. This point we got minus 1 comma 1. We solve the point of intersection. This is 0, 0. That means this line, this is 1. And this line, if you draw this line, minus 1. So between minus 1 to 1, you should find required area. But again, this graph is symmetric with respect to y-axis. This is symmetric with respect to y-axis. Then again, for required area is equal to required area. So I can write required area equal to 2 into 0 to 1. 0 to upper curve is y equal to x. I can write upper curve y equal to x minus lower curve is parabola. Parabola y equal to x square. So this is the equation. This is the parabola line. This is the parabola. So you can think about this is a parabola. This is y equal to x square parabola. Y equal to x square parabola. This is parabola shape. I drawn parabola shape, green color, that red color parabola, this one. Because here I can write x minus x square dx. X minus x square dx. So how sir, upper curve minus lower curve? Upper curve is line y equal to, lower curve is parabola. Correct. Because the graph, the parabola graph, when I have taken the parabola graph is always y equal to x square, means I will tell you that. I will remind you that the graph, the parabola, I will remind you that the graph, what I have drawn this. See, here you can simplify, you can integrate this. Right, this is a required area. When I will take a required area, 2 into, so x means this is minus, x means x square by 2 minus x cube by 3, limit 0 to 1. If I apply this upper limit, 1 by 2 minus 1 by 3, so it comes 2 into 1 by 6. So final answer 1 by 3 square units is 1 by 6 square units. That will be required answer. 1 by 3 square units. So you should be careful here that figure, try to understand here. Here any confusion, the graph y equal to x square, just I'm getting an idea about this. When you're talking y equal to x square graph means, so these are right, this is a figure here. Solve the equation, you draw the graph, then you find required area, substitute this is the graph. Generally, remember y equal to x square graph means the graph, if we think always this upward parabola, right? You will get the graph will be like this. This is y equal to x square graph. Just I'm telling here, any confusion means, here I have taken mod x, I have taken. This is mod x, because I can draw the line. Mod x, I have drawn the line. So this is the graph required here. Graph, I combined with that. Just write on the y equal to x square, y equal to mod x passing through horizon. This will be straight line, not curve this one. I can draw the line like joining this. Like this you can find required area. Okay. Now see now, here I will explain the next one now. The fifth problem. It takes only another 5 to 10 minutes. I can complete the session. I have understood this, right? Is clear, I think. Is clear. So then I can repeat the next one, the fifth problem. Find the area bounded by. Find the area, right? Find the area bounded by the curve y equal to x into mod x, x-axis, and the lines x equal to minus 3 and x equal to 3. This is also one of the important problem, this one. One of the important problem, just you observe this one. find the area bounded by the curve. Find the area bounded by the curve. Bounded by the curve. Y equal to x into mod x. Y equal to x into mod x. X-axis, let's say x into mod x. They are mentioning x-axis. And the lines x equal to 3, x equal to minus 3, and x equal to 3. Find the area bounded by the curve y equal to x into mod x, x-axis, x equal to minus 3, and x equal to 3. X equal to 3. This is a simple here. Draw the graph and doing the problem simple only. See, when they have taken here, think, when x is positive, when x is greater than or equal to 0, positive, the graph will become, mod x is equal to x. When x is 0, mod x equal to, you remember the graph, mod x equal to x, when x is greater than or equal to 0, and minus x when x less than 0. Correct? This will be minus x less than 0. Here x greater than or equal to 0. Here x less than 0. Then in this case the graph will become, you can see here, when I have taken y equal to x square when x greater than or equal to, correct, it comes y equal to minus x square when x less than 0. Correct? It will come like this. X less than 0, y equal to minus x square. Now they are asking area between minus 3 to 3. You know the shape of the parabola y equal to x square. Just now I have discussed about that. This is the important here. To drawing the graph is important here. Then you will understand this one. You can see y equal to x square, x greater than 0. So the shape of the parabola, it will come like this, upward parabola, but only positive part they are considering. X should be 0 or greater than or equal to 0. Then I should consider the graph only, this right side part. It will go like this. So this is y equal to x square when x greater than or equal to 0. Only one side I have taken. This is only one side, x greater than or equal to 0. But if we take negative downward parabola, that will be downward parabola, opens downward, y minus x, x less than 0, negative side. So we know that this is origin. They are talking negative side now. When they are talking negative side, the parabola will come like this. Because it will come down. Correct, the parabola will come like this. So you could think joining like this, the parabola, see here, it will come down like this. So passing through this one, now towards this side it will come right. Here only just, it will come like this. This is y equal to minus x square, when x is negative. This is y equal to minus x square. Y equal to minus x square. Between, they are asking minus 3 to 3. You take the point between minus 3 to 3 means I can take the point here. This is the point here. You take minus 3 to 3. So for example, you take, this is minus, this is 3, this side. X-axis, and this is x dash. X dash. They put this is minus 3. I can draw the line. So this is minus 3. Between minus 3 to 3 there are between minus 3 to 3. So what is the required area here? Now I can share, this is the required area. The shading in between. Correct, this is the required area. 0 to 3. Here also this is symmetric. You see 0 to 3, how much is there? Minus 3 to 0 is the same. This is symmetric with respect to y-axis. So this is y-axis. It is symmetric with respect to y-axis. Now required area equal to, I can write required area is equal to, the graph will be simple and I can write required area is equal to required area equal to 2 into 0 to 3, 0 to 3, because this is symmetric with respect to y-axis. This is a curve y equal x square, upper curve minus lower curve. I can consider upper curve y equal x square, lower curve y, this is x y equal to 0, difference of this. I can write upper curve minus lower curve, x square minus 0 x square dx. Now easy to solve this problem now. Right? I can write what is x square dx cube by 3. I can write 2 into x cube by 3, 0 to 3 limits, right? Zero to 3. Substitute the upper limit. We'll get 27 by 3. X cube by 3 means 27 by 3. It will be 9. Then you will get 18 square units. The answer will be 18 square units. You can write 18 square units. 18 square units. That will be your answer. 18 square units. Next one. That it won't take time. Another 2-3 problems. It takes next sixth problem. It takes another 6 to 7 minutes. So I'm doing the next one. There's a sixth problem. I'm going to explain the sixth problem. Right. The sixth one. Find the area of the region bounded by. Find the area of the region bounded by. Find the area of the region bounded by y is equal to mod x minus 1 and y is equal to 1. Y equal to mod x minus 1. This y is equal to mod x minus 1, mod x minus 1 and y is equal to 1. Area of the region bounded by mod x minus 1 and y is equal to 1. Y is equal to 1. So you again definition of the mod x. You remember I can write definition of mod x. So y is equal to, when x greater than or equal to 1, this will be x minus 1. It comes x minus 1. X minus 1. When x greater than or equal to 1. Equal to minus of x minus 1. When x less than 1. When x less than 1. You remember this. If you draw the graph, this will be easy to draw the graph. Y equal x minus 1. The lines. You draw the graph of this one. See, you should be careful here. The still put the line is coming. And I have taken like this. Here what I will do here, y-axis and x-axis. I have taken origin here. The given graph x minus 1 x, because they are talking x greater than or equal to 1. So you take the value, this is 1, greater than or equal to 1. When greater than or equal to 1, the graph will go y equal to x minus 1. When put x equal to 1, this will be 0. The graph will go above like this. You can see here. It will go like this. So this is y equal to x minus 1. Y equal to x minus 1. Similarly, minus of x minus 1. Left of 1 it comes like this. The graph will come. Left of this is y equal to minus of x minus 1. The graph will come. They are asking, and y is equal to 1. Y is equal to 1. You see, in the graph put x equal to 0, y value 1 only. It comes, this is y equal to 1. the graph it come like it intersects like this, right? So this is y equal to 1. That means the required area is this one. They shaded this is the required area. This one they are asking. This is the required area. In between the shaded part. This is shaded part. Right. I think this is the required area. Again, this graph was symmetric with respect to line x equal to 1. With respect to x equal to 1 also symmetric this graph here. You can see here. This is symmetric with this. How much area between 0 to 1 will be similar to that? This is a triangle here. You get triangle between the line y is equal to 1. So this is the required area. So here easily I can do that. The required area. Correct. So inside only. Then this required area easily what I will do now, instead of this one, I can make it, instead of I can find 0 to 1, 1 to this point of intersection. Because we know easily we can find point of intersection. This y equal to 1. Substitute y equal to 1 in the line. Here you can write the points here. This is the line y equal to, substitute the points. You can get the common points right. In the parabola equation, you take the line y equal to x minus 1 and this point. Where when y is equal to 1, x is equal to 2, this point will be 2, 1. This point will be, when x equal to 0. When x equal to 0, the y is equal to 1. This point will be, 0, 1. This point. Correct. Now I can consider 0 to 1. I will find because this exactly, you can think it is symmetric with respect to the line x equal to 1. You can think. If we think it is symmetric with respect to line x equal to 1, no, you can see here, if you extend the line, no, it's coming cross, but you can think easily, exactly it divides two parts, 0 to 1. I will find the area between 0 to 1, I will double it, it is the required area. Since it is symmetric with respect to the line x is equal to 1. Or else you can find area 0 to 1, 1 to 2 also I can find. I am finding 0 to 1. Required area equal to required area equal to required 2 into 0 to 1. Upper curve is line y is equal to 1 minus lower curve is minus of x minus 1. So it will come minus of x minus 1. It will come minus of minus plus x minus 1. Dx it comes. So this is curve. Upper curve, lower curve is y minus of x minus 1. Upper curve is lower curve. Minus of minus plus. It will come now. If we simplify this is dx. Here plus 1 minus 1 cancel. This will be integral 2 into 0 to 1 x dx. 2 into you will get x square by 2 0 to 1. It comes 2 into 1 by 2. Answer will be 1 square unit. Answer is 1 square unit. That will be our answer, 1 square unit. The seventh problem. I completed this. The seventh one. There is another one. The seventh one. I am going to explain the seventh one now. Just you observe this. This is sixth one over now. Next seventh one. The seventh one, because using the integration, the seventh problem, using integration, find the area of the region using integration. Using integration, find the area of the region bounded by y is equal to 1 plus mod x plus 1. Y equal to 1 plus mod x plus 1. X equal to minus 2. The lines are given here. X equal to minus 2. Comma x equal to 3. X equal to 3 and y equal to 0. Using integration, find the area of the region bounded by y equal to 1 plus mod x plus 1. This is 1 plus mod x plus 1, and the lines x equal to minus 2, x equal to 3, and y equal to 0. Y equal to 0. See, in this problem they are asking here to find area of this y equal to 1 plus mod x plus 1. Again, you can think the graph of mod x plus 1. First you think, whatever the graph of everything, when x is x plus 1, when x value, if it is greater than or equal to, you can see the value, we can split this. The given y is equal to mod x plus 1. Mod x plus 1, right? You should split the graph here in this. When x value more than minus 1, it will become 1 plus x plus 1. The graph will become y equal to x plus 2. Correct. You can think this graph, again think about mod x plus 1. So always you remember mod x plus 1 is equal to, it comes x plus 1, x plus 1, when x is greater than or equal to minus 1, equal to minus of x plus 1, minus of x plus 1, when x less than minus 1, x less than minus 1. Using this, I can decide now the value of this. I can write what is y value, I can write now. So y is equal to, if you take x plus 1, this will be x plus 2 when x is greater than or equal to minus 1. Minus of, if you write minus of x plus 1, 1 minus x minus 1, it will be equal to y equal to minus x is equal to minus x. It will be equal to minus x when x less than minus 1. When x less than minus 1. If you get an idea, this is now easy to draw the line, to sketch the graph. See now here I can write. You can consider, right. Drawing the line on vertical, yeah. You draw this line. Now you can think this is y axis and considering x axis and x dash. I have taken this is x dash. Y I have taken this is origin. Now you can see here when I have taken like this, the graph at minus 1, x greater than minus 1, this will be, I can consider this is the value minus 1, we are adding 1 plus y equal x plus 2. The graph. The graph always important point here. 1 plus mod x plus 1. 1 plus mod x plus 1. This is the final graph. When they are talking mod x plus 1, adding 1 unit for that. So y equal to 1 plus mod x plus 1. Y equal to 1 plus mod x plus 1 means if we take the value x greater than or equal to minus 1. The most important point here. When I have taken this is a minus 1 here. This is a minus 1. The graph will come like this because at x equal to minus 1, the graph will come 1. The value minus 1 plus 2. 1 in the height of 1 it comes. The graph will go. This line it comes now. From here I can extend the line. This is y equal to x plus 2. Y equal to x plus 2. Left of minus 1, y equal to minus x. From here, left of minus 1. The line it will come like this. Correct? This is the point here. They are asking the area between minus 2, 3. So 3 means I can draw this line. I can extend here the line x equal to 3. So draw the vertical line. Now consider vertical line only. It's coming. See, if I draw this one, this is 3. They told x equal to 3 and x equal to minus 2 we consider, you will get x equal to minus 2. Right? They are asking area now. See, between minus 2 to 3 and y equal to 0. So this is the required area total. We are splitting the graph at x equal to minus 1. So you can think at x equal to minus 1. This is the required area. You can see here I can shade this required area. This is required area. This is the everything. Between also I should get -2 to -1. By this graph it will come like this. Because they told here, and one more line, y equal to 0, this one. Y equal to 0. This is the, I can find, this is the required area. Between these lines. Correct, this is the required area. So I can split -2 to -1. I can split -2 to -1 and -1, 2, 3 I can write. That will be completed now. Required area equal to, I will write required area between -2 to -1. Between -1 to -1. This is the function. Upper curve is this line, we know this is y equal to -x. This upper curve, lower curve is y equal to 0. It will come -x dx. -x dx plus -1, 2, 3. I should consider between -1, 2, 3. Between -1, 2, 3. Upper line y equal x plus 2. Along with x-axis y equal to 0. It will come now x plus 2 dx. X plus 2 dx. Now if you find this, it will come now. This will be -x square by 2. -x square by 2. Limits -2 to 1. Just you write this one. I can write here -x square by 2. Limits -2 to -1. This will come x square by 2 plus 2x. Limits -1 to 3. -1 to 3. Now if I simplify, it gives the required answer now. -1 to 3. So this will become now. So if you apply the upper limit and lower limit here, you can simplify here. This will become minus of, apply the limit of 1 by 2 minus, it will come 4 by 2, 2 plus this will become 9 by 2 plus 6. You simplify this, 9 by 2 plus 6 minus lower limit, it will come minus of 1 by 2 minus 2. 1 by 2 minus 2. You simplify everything, this one. The upper limit minus lower limit. 1 by 2 minus 2. So this will become 1 by 2 minus 2. This will become 3 by 2. By 2. You can see here. This one you can write. This will become here 9 by 2 plus, you can write this one, 1 by 2 minus 6 means, you can see 12 plus 9, 21. 21 by 2 plus 3 by 2. 24, but you will get, this is also 3 by 2. 21 by 2, all this you can add, all having denominator 3, only 21 plus 3. Right. 21 plus 3, 24, 27 by 2. You get 27 by 2. Correct? That will come here. 27 by 2 is the required square units. That is your required answer. 27 by square units is your required answer. 27 by 2 square units. 27 by 2 square units. The next, another one. So it takes another 3-4 minutes, I think. Yes, we got it, this one, 27 by 2 square units. Find the area bounded by the curves. Y equal to mod x plus y. I have another 2 problems. I will explain the 2 problems in the tomorrow session. I can explain. Just I will show you now the 2 problems. Otherwise, if you are okay means I can explain now. Otherwise, I can do question number 8 and 9. I can solve the tomorrow. I can solve that question number 8 and 9. I will show you that 8 and 9. The questions 8 and 9. I can start with 8 and 9. See the question number. Just I will mark you now here. The question number 8 and 9. So I think the next session tomorrow I can start with this. You can see this. So tomorrow session I will discuss mod x plus y is equal to 1 and x-axis. And x-axis, this I will discuss question number 8. Question number 8 and question number 9. This is the 8th question and question number 9. Tomorrow I will discuss. I will start with this. Using integration, find the area bounded by the curve mod x plus mod y. Mod x plus mod y equal to 1. These two I will discuss next class. Next session I will do this. These two I will discuss mod x plus y is equal to 1 and x-axis. And area bounded by the curve mod x plus mod y is equal to 1 I will discuss in the next class. Then see you. Right, these two problems discussed tomorrow I will discuss. Then thank you. See you tomorrow. Then see you in the next class. I can explain that. Fine. Thank you. See you in the next class. If you like the session, you can if you understood the problems, please like the session. Fine. Everyone, after copying this, it's clear like the session.